So it doesn't matter if you're a seasoned pro or just starting out in the lab. There's one thing that can flip a totally normal day into a crisis in a heartbeat: a chemical spill. And knowing what to do, well, that's not just some rule in a dusty safety manual. It's the one skill that turns pure panic into a solid plan and chaos into control.
Okay, just picture it. You hear that sound of glass shattering. You see a liquid spreading out across the bench top. Your heart starts pounding, right? What do? That very first move, what you decide in that split second, that's exactly what we're going to break down today. First things first, let's make sure we're all on the same page. What even is a spill? Well, officially, it's any time a hazardous chemical gets out of its container. And here's the thing you gotta remember. We're not just talking about puddles on the floor. A spill can be solids, like powders, or even invisible gases and vapors that are escaping into the air you're breathing. Now, when you're staring at that spill, you don't have time to go dig up a textbook. You have to make one single decision. And honestly, it's the most important one you'll make. Is this a simple spill I can handle, or is this a complex emergency? Because how you answer that changes everything. And that difference is absolutely critical. Look, you can totally handle a simple spill, but only if you know what the chemical is, you understand its hazards, you have the right gear to protect yourself, and you've got a spill kit ready to go. But the second that spill puts other people in danger, or fills the room with toxic fumes, or someone gets seriously hurt, that's not simple anymore. That's a complex spill, and your next move has to be instant. Want to see what that looks like in the real world? It's pretty stark. On the one hand, you have a simple spill of salt crystals. Annoying, sure, but totally manageable. On the other hand, you have shattered vials of nitrogen tetroxide gas. That's not just a spill, it's a lethal emergency, and the only right answer is to get out. And let me be perfectly clear about that. For any complex spill, there's no debate, there's no discussion. Don't try to be a hero, don't think you can fix it. You have one job: get yourself and everyone else out of there and call 911. That's it. Your safety and everyone else's depends on that one simple rule. Okay, so we've got the big, scary emergency covered. Now, let's pivot to the scenario you're actually much more likely to run into. Let's build a practical, step-by-step action plan for those simple spills that you can and should manage yourself. All right, here are the first 5 steps, and trust me, the order here is really important. First, get anyone who isn't involved away from the spill. Just clear the immediate area. Second, is anyone hurt? Deal with that immediately. First aid comes first. Third, you gotta know what you're dealing with. Find that chemicals safety data sheet, the SDS. It tells you all the risks. Fourth, tell someone. Never, ever handle a spill alone. And fifth, only after you've done all that is it time to put on your PPE, your personal protective equipment. And when it's time to actually contain that spill, you might be surprised at what's in your lab spill kit. I mean, kitty litter? Yep. It's actually a fantastic tool because it's cheap, easy to get, and super absorbent. It does the job. Okay, so once the scene is secure, we move into cleanup. Get some air moving, open a window, turn on a fume hood. Use that kitty litter or special absorbent pads to contain the spill to stop it from spreading. Then clean it all up. Dispose of the waste exactly how your lab's procedure tells you to. And finally, and you cannot skip this part, fill out a detailed report. Why? Because that report is how we all learn and how we stop the next accident from happening. But you know, cleaning up a mess is one thing. Being smart enough to not make the mess in the first place, now that's the real goal. So let's zoom out. Let's shift our thinking from just reacting to spills to the much bigger, much more important picture of preventing them altogether. So how do we do that? We start by understanding risk. And risk isn't just some vague idea of bad luck. It's a calculation. It's where the severity of a hazard, how bad it can hurt you, smashes right into the likelihood of you being exposed to it. The whole game is about understanding these factors so you can stay out of that dangerous red zone. And each one of these factors, think of it like a lever you can pull to make things safer. For example, just by reducing the quantity of a dangerous chemical you're working with, or by properly checking the age of old chemicals to make sure they haven't become unstable over time, you can dramatically lower your risk. Let's really drill down on that idea of quantity, because there's a 500-year-old quote that says it perfectly. The dose makes the poison. Think about it. Even something you might have in your kitchen, like pure caffeine powder, can be absolutely lethal in a large enough dose. We're talking a couple of teaspoons is like drinking 50 to 100 cups of coffee all at once.
It's all about the dose. And of course, just look around you. Your environment itself is a massive factor. I mean, a cluttered lab like this one, it's just an accident waiting to happen. It's full of trip hazards, which makes a spill more likely, and it makes it harder to even get to the safety shower if you need it. It's simple. A clean lab is a safe lab. So all of this, it brings us to the most important concept in this entire explainer. Seriously, this is the master key to lab safety. It's a professional framework for creating the safest possible environments, and it's called the hierarchy of controls.
So let me ask you a question. What do you think is the single most effective way to stop an accident with a dangerous chemical from happening? Is it wearing thicker gloves? Maybe better goggles? The real answer might surprise you.
And here it is, the hierarchy of controls. It looks like an upside-down pyramid, and the whole idea is that the safety controls at the top are way more effective than the ones at the bottom. You see, true safety isn't about how you react to a danger, it's about getting rid of the danger altogether. Let's run through it, from most effective to least. At the very top, the best thing you can do is elimination. Just get rid of the hazardous chemical completely. Can't do that? Okay. Next best is substitution. Swap it out for something safer. Below that, you have engineering controls, things like a fume hood that put a physical barrier between you and the hazard. Then come administrative controls, which is changing how people work through training and procedures. And way down at the bottom, the very last resort, is PPE, your goggles, your gloves, your lab coat. So, if you remember just one thing from our time together, let it be this. Your safety goggles are your last line of defense, not your first. They are there to protect you only when every single one of the better, more effective controls, elimination, substitution, engineering, has already failed. That single idea should completely change how you think about safety. So I'll leave you with this question. Next time you're in the lab, instead of just automatically reaching for your gloves and goggles, take a second. Look at your workspace, look at your procedures, and ask yourself, how am I going to use this hierarchy to make my lab a fundamentally safer place tomorrow?